Hi everyone, today's lesson is trigonometry and we're going to look at angles of elevation and depression. So an angle of elevation is the angle above the horizontal line between the line of sight and the horizontal. So I know that sounds a little bit complicated, but basically all that means is it's usually made with the ground and it increases, so it goes up. So just think elevation increasing. Or moving up to the point that you're looking at. The angle of depression can be a little bit more complicated because it's not at the top of the triangle. It's actually the angle below the horizontal line between the line of sight and the horizontal. So it goes from the horizontal down to the thing that you're looking at. So just think about depression as decreasing or moving down. Now there's a neat relationship between the angle of elevation and the angle of depression. And that is that they are equal to each other. So in angle theory, because the horizontal line at the top and the horizontal line at the bottom are parallel, that means the angle of depression and the angle of elevation are exactly the same. And this is because of the alternate interior angles theorem. The most important takeaway from you is that both the angle of depression and elevation are equal. Just note, sometimes you'll hear elevation talked about as the angle of inclination or incline. Again, still just means going up. So with this information that they are equal, both the angle of elevation and the angle of depression, you can use that to help you solve some real-world problems. So let's have a look. Problem number 1. From the top of the Eiffel Tower, the angle of depression of a bus on the road below is 56 degrees. So our angle of depression is here. And what we know about our angle of depression and our angle of elevation is that they're equal. So we can make this angle 56 degrees. We know that this is our right angle. The question asks us to use a scale drawing to find the distance of the bus from the base of the Eiffel Tower. So we're looking for this horizontal distance here. Let's go solve. So the first thing we're going to do is we're going to label our triangle. So we know straight across from the right angle is our hypotenuse. And opposite our indicated angle, we'll find our opposite side. And our third side is our adjacent side. So because we're dealing with our adjacent and opposite, that means we're going to use our tangent ratio. So again, on the top of anything that I'm doing, I always put my little mnemonic up here, SOHCAHTOA, so that I can easily select the correct one. And in this case, we're dealing with opposite and adjacent, so we'll choose tan. All right, so tan theta, which is 56, is equal to my opposite side divided by my adjacent side. So I'm just going to set up my proportions here. I'm going to solve for x, which will end up being 300 divided by tan 56, giving a final answer of x equal to 202 meters. So that means the bus is 202 meters away from the Eiffel Tower. Make sure you clearly indicate that. And if we look, we know the Eiffel Tower is about 300 meters. 202 meters makes sense in this situation. Let's look at example number 2. The Burj Khalifa is the tallest building in the world. From point X on the ground, which is 500 meters from the base, the angle of elevation is 59 degrees. So what we're actually going to do here is we're going to figure out how tall the building is. So we're going to begin by labeling our triangle. Okay, so we know that this is our opposite side. This would be our 90 degrees, making this our hypotenuse. And the other side remaining attached to the angle is the adjacent side. And we're going to write our mnemonic on the top. Some old houses can't always have two old attics. And in this case, we're looking at our adjacent and opposite side. So again, we're going to use tan for this one. So here we have tan 59 is equal to opposite, which we don't know, over the adjacent side. And I'm just going to set that up as a ratio where x will be equal to 500 multiplied by tan 59, giving us the height of the building, which is 832 meters tall, which would make it pretty tall, hey? So that's almost a kilometer into the sky. So there you go. There are two examples introducing the concept of angle of elevation and depression. Please go back to the assignment, and I'd like you to do the student-paced Nearpod activity that's there before moving on to our next set of questions.